Hello, everybody. And this is Ted Knack from Certainty 3D here with another release, TopoDOT release, kind of latest and greatest, and kind of keep you guys up to date on what we're doing. I've got Mouty Turnius is going to show you all the good stuff. And those of you who are showing up on the second time here for the 2 o'clock presentation that didn't make it in the first, we're sorry. We were limited to 100 people in our webinars. It costs a lot of money to get to the $500 level, and we only kind of need it for these updates, so we're running the 2. So just be aware in the future, if you can't get in one, try to get in the other, or they'll be recorded so you can always, catch up later. Anyway, so welcome. Hope everybody's having a good day. Let's just get started. Okay, so again, this is release 10.6. Just the highlights of that release. There's a lot of bug fixes, things like that. Not that we ever have bugs, but they're all taken care of. But we're going to show you some of the new features, and some of them are very significant, so I think it's worthwhile. So let me get a few things set up here. Okay, so the first thing we'd like to do is just kind of show you what the new features and what the new things will be. We'll talk about it a little bit, and then Mouty will show you how they work. So for those of you new to TopoDOT, it's kind of the way we run it. We'll talk a little bit about what the significance of these tools are, and then how they're used in the field. So this first one is the vertical clearance tool. Many of you know there's been a bridge clearance tool. It's still called bridge clearance, although you can use it for other things. But the bottom. What's
yeah,
that?
you're sharing the wrong screen.
I'm sharing the wrong screen. Okay, thank you.
Yep.
All right, yeah, I forgot to do that. Let me change that. Okay, this will go out much better. Thanks, Mouty. I think I know that by now. Okay, so the new feature is vertical clearance tool, and it's kind of like the next level performance past our bridge clearance, where in the bridge clearance, if you guys recall, we just from a top view, you can make one, just draw a line, and it'll basically cut a cross section and give you all the clearances to bridge beams, lowest clearance, depending on what mode you picked it in, lowest clearance along that line, things like that. Still a very useful tool, but they are all vertical clearances. What we realized now that wasn't quite adequate for doing a typical bridge clearance analysis. When you do bridge clearance and rail clearance or anything like that, there's two criteria. Fundamentally, first of all, they're looking for the lowest clearance anywhere along like say a lane, and that could be any kind of pipe, anything hanging down. So you basically have to look at all the data, which can be time consuming, as opposed to just getting a single line with a thickness. You want to look at that whole lane, which we look at a lane at a time here. And it also, and the big criteria is that those measurements have to be orthogonal to the super elevation of the road. So basically, so instead of being vertical clearances, they actually have to be orthogonal to the road, the gradient or the angle of the road. And the same for rail. So if you look at our left picture here, we have just the lowest and the highest clearance but in a lane under a bridge. If you look at our right, that's we used in doing rail, and then in this one we just selected the option to look at every, say, I don't know what that was, maybe 10 feet or so. Looks like it was a meter, so maybe every 2-3 meters. And then within those 2 or 3 meters, it'll find the lowest point. In the case here, it actually color codes. You can put a gradient, so you'll see every measurement. They're not evenly spaced because it'll always be the lowest point. And then it'll also give you the absolute lowest point, which is a big red dot, and the highest point, which is a big green. So the bottom line is, from the top, you can see the trends as they're happening, in the top view, and then of course you can see the individual measurements down here. So again, just to show you how that works, these measurements are taken like this. So in the road tool, we want you to find the road lane. That's the only kind of pre-processing you have to do. Just give us lane boundaries. Obviously, the stripe is the easiest way to do it. If you don't have a stripe, just lay a line down. That's very easy to do. at the edge of the road, and then give us an offset. Mally will show these parameters, but basically what we're doing is we're determining pretty much where the wheels will ride, because that's going to give you your elevation. And I'm sorry, that's going to give you your inclination or your super elevation of the road, and those 2 points, right? So you don't have to, fitting a plane and thing like that isn't the best way to do it. We know that's been done. For example, the manual approach from some other softwares was just finding maybe a 2x2 foot plane here and a 2x2 foot plane here. As we looked at it, that's not really what the elevation is. This could be a rut or something like that, which will throw it all off. You weren't getting the right measurement. So we think just 2 points here and here with a line in between them, that actually tells us what our angle is. And then we measure that angle, we measure from the point cloud on top to the point cloud on the bottom, not the line, the point cloud. So we give you all those measurements. And when we register in each segment, whatever you say, like about 10 feet, 5 feet, whatever, we'll give you the lowest point in that segment. And of course, we'll mark the highest and lowest. Same thing here with rail, just a little different in that we look at the rail line. So you have to extract the rail lines first. That's very automatic in TopoDOT. You guys should know how to do that. If you don't, please give us a call. You just basically take your cell, put your rail cell down, and it automatically gets the rail. You get 2 brake lines on the rail, either inside rail, whatever, top of rail. And then we'll automatically look through that to you. In this case, we're looking at the distance to the cross section of the cable, and then we'll just basically say, okay, what's the lowest point orthogonal to this line? So that's the way this works. We'll show you, Maddie will show you that live, but you get a feel for why that's important. And we've automated it. This used to take literally hours to do a bridge. It takes seconds now. So please think about that next time you're looking for this kind of information. New feature, also an encroachment clearance tool. And most of you might know that we had the ability always to classify points. Classified our point cloud, and a lot of that classification we actually use the encroachment tool to understand within an area or volume which points were intersected that. So in this particular case, what we do is Mally's added a feature where we can take a cable or a polyline, and then we can actually first identify those points, doing the classification, classify those points, and then we'll automatically go through and actually measure the closest point within that clump of points to your polyline, orthogonal distance. So basically, it's measuring it for you. So if you have to give a report with measurements out, this is done automatically now instead of you having to go in and physically measure each one. So very fast, saves a lot of time. And we'll show you that also. New feature, it's an export image overview image tool. Kind of interesting. We didn't think of this. Someone asked for it from our customers. And what this does is it takes the point cloud. If you look at the image here, you have a point cloud, a 3D point cloud within its tile overhead. And then you have this image of the point cloud below it, which is basically, so we take out the third dimension and we make a raster out of it. So we take out the elevation dimension, make a raster out of it. That is then it's an orthophoto of the point cloud, obviously. And that's very useful. You can take those photos and you can actually pass them on to engineers and people that may not want to see a point cloud, but you can pull them in as rasters, and you can do obviously 2D measurements, compare them to plan views, compare them to your model, outside of the point cloud realm. Nobody has to have a point cloud for that. So we can export these images. Very powerful. We can see the usefulness of that. And so if you're trying to, again, talk to your engineers, give your customers something that they can, not much processing involved, just basically export this, they can look at the lines themselves. So it's pretty powerful. Smart B-spline portion of selected line tools. I don't have an image for this. I was going to, but basically Mally will show you. It's just a cool CAD feature where we actually just save you a lot of time when you're cleaning up your CAD model. if you have kind of lines, basically big arcs or so whatever that are maybe you want to smooth them out. We do, Maudy has found a way to do that automatically. So we'll show you that. Sorry, I didn't have a picture there. I just didn't get to that yesterday. What we want to do is actually tell you it's official. We are releasing the TopoDOT for Estuary. We don't have the licensing done yet, but don't worry about that. Everything's through 2018, or I'm sorry, up through 2017. We're just letting you use it. We're still organizing how we're going to basically charge for basically the license fee for this tool, but but functionally it's released. And the bottom line is what you're going to do is the way it works, for those of you who don't know, who might be new to TopoDOT, is that you can actually take all your point cloud, all your images into an Estuary environment through our TopoDOT for Estuary module. So let me show you how a little bit of what we do. We do something called DPEGs, and the way this whole operation works is that the DPEG is a depth photo exchange graphic, and what we do is we extract these DPEGs automatically inside of TopoDOT for Bentley. So it'll go through and find every image that you identify. You don't have to take all the images, but every JPEG, every calibrated image, they must be very tightly calibrated for this to work well. And then basically it'll take the other layers of information and put them in multiple channels into one compact file. So now instead of say this image, this JPEG image, is one that was taken from a mobile LiDAR system, TopoDOT automatically extracted the intensity that goes along with that, and also the geospatial information, which is the point cloud. Each of these is a range point that corresponds to a pixel. So if you imagine you just overlaid over each other, and then when you click on the JPEG, you'll get the range information in the back, and you basically be able to extract measurements, locations, things like that. This 4 meg file only goes up to about 7 meg with this information, so it's very easy now to take these images into an ARC map environment, which isn't supposed to take point clouds, but now we can do it. Or ArcGIS Pro, of course, and also the Desktop Explorer. Again, right now the way it's going to work is you'll buy a license from us to create DPEGs from your typically your mobile LiDAR data. It can be any calibrated image data with point clouds, but typically we see this being mobile LiDAR. And basically they'll do it automatically, and then these DPEGs, you can put them up on the cloud. You can put them on your server, you can put them on Amazon server, and anyone can click in the map and the right image will come up, and it'll tell you, it'll tell you where, it'll find the image for you automatically. You can cycle through them, and then if you want to click on here, you can measure. You'll see that. Maddie will do a little demonstration of that. So that's it. Again, the nice part, why DPEGs, they're just efficient, easy, and ready. There's no, this is ready to go. There's no big IT, requirements. Basically, these images will download quickly. You don't have to stream data. And again, we're just on the DPEG. We only charge on the DPEG production side. On the DPEG news, using it in this particular viewer that we've got now, let's call it viewer. I'm sorry, TopoDOT for Estuary. It's more than a viewer, much more actually. But basically, TopoDOT for Estuary you can install anywhere you like. So you can just give it to once you've made your DPEGs, you can just pass it on to your customers, or your internal or external customers. Okay, so the data storage is very fast and it's low cost, again, and it's very easy to use. We can teach anybody how to use this in 10 minutes. So think about that and let us know if you're interested. We will let you have that. And we'll set you up with that, and you can try it out and see how you might be able to make use of it. Okay, all right. That's it. So question, we're going to turn it over to, if there isn't any questions, I doubt there will be yet. We'll turn it over to Maudy, and he'll show you how everything I talked about works, and then we'll talk a little bit more. So Maudy, I'm going to turn it over to you.
Okay.
All right.
Okay. All right, guys. So Ted talked about a lot of the tools there. We're gonna go ahead and start off with the encroachment clearance tool here. So we've got a bunch of data loaded. This is of the power line data, actually behind our office. So I'm gonna go through a little bit of the tools that we already have available and we've had for years now. And the reason why is because you need to run those first before you use this encroachment clearance tool. So in this case, I've already extracted some of the power lines and the towers. So I'm going to go ahead and select those guys and start off by doing a quick classification of those wires and those towers. So to do that, you just come over here and you can say power line encroachments. Again, this is an old tool here, but basically you specify the classification that you want everything to go in and the distance that you want to classify as encroaching data. So this is about 12 feet from each wire it's going to process. And what that's going to do is go through there and flag areas red that that it found that's too close to the wires. Okay. So once I have that, I'm going to go ahead and turn off everything except for my encroachment data. All right. So you can see there it's flagged up some of the trees and things that are around that area there. And then we can start using the new tool we have available. So again, I'm going to go ahead and select all of my wires. All right, once I've got that, then we're going to go back in here and I'm going to use this encroachment clearance tool. You can specify the classification you want it to measure to. In this case, I'm going to use that encroachment level that has all of these red points. And then go ahead and click on process. And what this does, and Ted had mentioned it earlier, is it looks at all of the data here and it groups it into different objects. And it says, okay, this is one object, find the closest or the minimum clearance there to that object. And it does that for each one of those guys. So if I take this and rotate it around, you can, let me turn off the raster images there. Okay, so you can kind of see it basically for each one of those areas of data, it found the closest power line to it and found the minimum clearance from that object to the wire. Okay. So that's an option there.
So you can see how useful that is. I mean, if you had to, before we classified, you could find them, but you still had to measure, and it was still kind of a little somewhat manual. Now it's obviously automatic. While we're here, and I asked Maddie on the last one, could you show everybody the cluster tool? Everybody may not be may not be knowledgeable about that. This encroachment tool, you can do this in a lot of things. It's not just here. You can do encroachments. Just take data within a path, points that fall within a 2D shape of any shape down a path. We can do encroachments of a overhanging, basically the overhang of a retaining wall into a road or something like that. It doesn't have to be just trees. But anyway, what happens is once you get those points, we have we have an easy way of isolating those and grouping them so that then you can just export those as CAD elements, for downstream operations, so now, these are the only things you have to export when you want to dig downstream and tell your engineers, your maintenance people, what has to be trimmed, what's in the way, where the problems are, whatever. Okay, so just to let you know that tool is available. So I don't think there's anything else to say about that. Anything, Maddie?
No, that's it for that one.
Okay. Any questions out there? Everybody's okay? Pretty straightforward, but let us know. We had someone in the last meeting, this morning's meeting, saying they just had to find the closest point to a driveway, which basically turned out to be just the bridge clearance tool will work fine for them. Close distance from a fiber optic cable to a driveway. But I know these applications come up all the time, so please let us know if you want to find the right tool to work for you in the most productive way possible. Okay, so next thing we're going to do is, what are we going to do next, Matt?
So the next one here is going to be the B-spline tool that we added into the suite here. So let me go ahead and start up, and I've already got some sunline work extracted here. I won't go into how that was done too much, but go ahead and load in some data. All right. So in this case, you can see I've extracted some of the curb line here, but obviously in this area, I didn't quite put enough vertices to capture that rounded area too well. So one of the things that you added here to kind of add some extra detail to areas that you might not have extracted with that detail, you can come here to the TopoDOT extraction tab, select the break lines that you generated there. And if you go in here into your toolbox that has all your different B-spline things, you've got Smart B-spline portion of selected lines. And so if I select that, then it's going to let me basically select the start and end point of where I want to actually smooth out that data. So let me hide the point cloud for now so you can see it a little better. And so I'm going to say, okay, start here and finish there. And you can see it's highlighting all the selected lines that I had there. And then if I go ahead and accept that, what it does is that area that I told it to, it sticks a B-spline in there, but still retains it as a single line. So you don't have to reconnect it or anything like that. Now, some people don't like actual B-splines being used in there. So the other option, let me go ahead and undo that. And we'll click that tool again, is you have this facet mode, which is similar to the Smart B-spline tool. If anybody's used that before, basically I can say here, that you want to break it up and say maybe just put 10 line strings in there when you're smoothing that area out. And instead of a B-spline, it's actually sticking a bunch of little line segments. Okay. Or you have the other options in there, just to talk about them really quick. You've got max chord height, which is similar to like a key point type thing. So you can put like 0.1 and it'll put a bunch of little vertices in there too that changes depending on the to capture that detail there. And then you also have the fixed chord length, where you can say, for example, create line segments, but make sure they're all one foot in length or whatever distance you want. And then you saw the segment count, basically the number of line segments that you want there. Okay. Now, one thing to note with this though is, it's not the same as fitting an arc to an area. So in this particular case, you can see it's this little end of the curb. And I did two examples here. I did one example where we did we did straight segments there on the side of it, and then I just put one point here at the top end of the bull nose there. Now, if we were using the fit arc tools, this would go in here and fit that arc nicely. But if I try to B-spline this, which I'll show you here in a second, you'll see it's not quite going to be what you're expecting. So whereas with this other example, we've got a little bit more points there to guide our B-spline, it's going to give us a nicer result. Okay, so it's not going to be able to fill in everything for you, but it'll definitely be helpful for cleaning up certain areas. Right. So we're going to go ahead and run that one more time. I'm just going to leave it on facet mode for none so that it creates a B-spline there. And then we're just going to do that area at the end. And you can see the differences here of what it produces. So, it's basically just doing a B-spline through points, and it's saying, okay, force a point here, force a point here, force a point here. And to do that, it doesn't necessarily have to follow this area out here. So you can see the differences between the two and how you can apply that tool to your drawings, hopefully. Okay, so hopefully that makes sense there.
Yeah, sure. I mean, things like bullnose, you really want to use the other tools.
Right.
It's a great example of what it's doing. Obviously, it doesn't. One of the things we do on the bullnose tool are the what do you call it? 2 lines to an arc. I don't know what we call that tool, but might as well pull it down since we're talking about so much fit arc up in the right there. So all those tools, 2 lines at one point, we actually extend the line so that there's a smooth transition. You don't have that sharp angle that you have in that red line here, at the transition point. So that's why that works better too, I think. But the bottom line is, use the right tool for the right thing. I think that's really useful. Obviously, one of the reasons you pick line segments or stuff, and correct me if I'm wrong, I think is just how your DTM engine handles it. Some might like splines, some may not. Some want the line segments work better when you're making your DTM. So you just have to experiment a little bit. But you have a lot of tools there to do that. Anything else, Mally?
Not for this one, no. All right.
Okay. All right. So I guess the next thing we do is the clearance, correct?
Yep.
Okay.
All right, guys. So for this one, really quick, we're going to go through the new vertical clearance tool that we have available. So like Ted mentioned, we have to start off by extracting the lane boundaries, and the easiest way there is by doing the paint lines. Once you have that, then we can go ahead and open up the vertical clearance tool here. From there, you're going to select your project type, so either road or rail. So depending on what you do, if you do a road, it's basically going to use that wheel track to determine where the wheels ride to calculate that super elevation, like Ted had mentioned there in the presentation earlier. And if it's rail, it just does it from the top of the rails, and it determines the super elevation that way. You can calculate here. We want to make sure we measure orthogonal to that road surface. And then you've got some options in here that says basically that you want to calculate or plot the either all the clearances or the lowest and highest or just the lowest. I guess we'll start off here with just the lowest and the highest clearances. And then you can also choose how you want to color the results. So you can specify just color the min and the max and everything in between based off of the min and the max results. It'll color it between green and red. Or you can specify a limit or a threshold that says, okay, anything less than 20 is going to be magenta, at 20 is going to be red, and you can see the legend there to kind of see how that works. Okay, and you have some other options in there for creating sheets and things, but once you've got the paint lines extracted, all you need to do, let me go ahead and put that back to min-max. We're going to go ahead and select those paint lines. I'll say here data thickness of 5. Basically, it's going to analyze that road every 5 feet there. Click auto. All right, and in that case, it's going to go ahead and the low point is going to be flagged red. The green, there's the high of the low points. So the highest clearance with all the clearances there. And so it doesn't necessarily have to be, I know these kind of fell on the pretty close to the lane line itself, but these can be anywhere on that road surface. It's not just analyzing the line, it's that entire surface it's looking at. So, so yeah, you've got those. And just really quick here, we can run it also with the, let's do plot all clearances. All right, so here you're going to have a lot more results, but you can use this information to kind of help you determine, the maybe patterns or something like that. You can see this area is all pretty low clearance, so maybe you want to look at that a little bit further, or however you want to handle that. Okay, anything, Ted, you want to mention there?
No, I think that's it. I would just say when you're it's very fast and it'll find so I mean, this was taking a long time to do before. We had some of our friends in Oregon DOT, they were telling us how they did it. It was brutally long. This is all automatic. When you pick your data thickness, that's actually the way to think of it, that we have one super elevation reference for that data thickness. So you pick thicknesses, short enough that the super elevation of the road, the gradient, the slope of the road is going to be the same, over 5 feet. Nothing's going to happen much. You don't want to go make that 100 or anything like that. You start changing the elevation, getting curves, so you have some average of everything. But basically, it takes that one reference and then it goes every 5 feet and looks for it. There's a way of putting dots in the top too, I think, but I don't know, whatever. Mm-hmm. But you can see the trends in those colors. And there you're looking at more, we had customers who wanted to do, okay, okay, so anyway, I want to answer that question from Daniel Clark. But bottom line is, if you if you just select sections short enough to, that nothing changes much. Okay, so in other words, in that image that Matty's showing you, good job, Matty. Yeah, that's helpful. We use that reference for that entire 10 feet on the bottom. So we're just assuming nothing changes. Now, Daniel Clark asked, why do we need to extract lines if clearance tool will just find the distances in that area? The super elevation of the road can change, first of all, in each lane. So we have to know if we're going to, this is the way it's extracted. So it's a little different. We have to know, we need the lane line, so we know the offset, and then we know how we're going to figure out what the angle is, or what the gradient is of that 2 points that make up this, we call wheel track in this picture. But we have to know the slope of that line, because we're going to measure orthogonal to that. And so you have to do it lane by lane. Then, super elevation lanes will change. And so you can't, and then you really want to know the elevation of the road is going to be where the wheels travel. That's actually going to define what your super elevation of your road is. You don't want to fit planes in small areas, because they can be really far off. You can get a rut, and the plane in a small area can be not even close to what the elevation of the gradient of the road is. If that makes sense. So this is the way it's done by lane. So all you got to do is pull out those lane lines, select them, and say go find it. And it does it lane by lane, so you'll see measurements on each, in each lane. Okay, good. Thank you, Daniel. I'm glad you liked the answer. Okay, I was probably much more information than he was thinking. Great. Okay, no problem. I always do. It's the way it works. Anything else out there? Any other? You've got Matty, you've got his attention. So if there's, we don't want to turn into a training session, but if there's any deep questions you had about anything that has to do with this or other things, let us know. We'd be more than happy to show you right now. Okay. If there is anything else, Matty, we have anything else? You want to show a little bit of it?
Not yet. We're still got 2 more tools.
Oh, 2 more tools. I'm ahead of myself. I don't know. Having a tough day. Okay. 2 more tools.
All right. So the other thing here, we've got the export overview image.
Oh, I forgot.
Just a quick note is this is available only in 64-bit. And it's located here in the export tab. Just click export overview image. You've got 2 modes here. You can have it go through and unload and load all your data tiles automatically, and it'll create an image just for each data tile. Or you can say here, just run it on your loaded data set. And then you can choose your display mode. We'll go ahead and just do colored intensity. And then your pixel size basically is the size of a single pixel on the image. So in this case, 1/10 of a foot per pixel. And we'll say attach raster, because it's going to generate a world file along with this image. So we'll just go ahead and click generate. And let's stick it in here. So we'll give that a few seconds there. All right, and that's going to generate this image for us. So on top of that, like I mentioned, it also generates the world file, so it's able to come in here and actually attach it and reference it into our drawing where it should be. Okay, so this can be used for a variety of things. For example, if we were doing the encroachment data earlier, maybe you want to generate just an overview image of the areas that need to be chopped down. Would be one example. Or maybe you just want to give a simple, just a simple image to pass along that shows where all the paint lines are, or something like that. So I mean, it's got a variety of uses. We'll let you guys figure that out, but that's an option.
Yeah, I think it's just another way of really communicating with outside the point cloud, wherever we call it. I mean, again, we know everybody doesn't have TopoDOT. We wish they would, but your engineers or somebody just might want to say, okay, I have this great data. There's all your line work. I mean, if they just want to know where the lines, how it matches up to some design they have or something like that, you can extract all the lines and show them the lines, or you can just make these ortho images and bang, send it to them and say, here, open them up, the rasters, see how things line up. It saves you a lot of work with. It can save you a lot of work with trying to extract. When maybe you don't really have to. Okay.
All right. So the next thing here is the template by fence. So let me go ahead and switch project here. All right, so all right, so here we've got a bunch of beams here. So quick little data set. Now, in the past, we've hopefully everybody's familiar with the template extraction tools, where you are able to just draw a shape, either of a curb, a barrier, or guardrail, or anything like that, and have the tool automatically follow and extract it. Now, what we've noticed though is that in features that are sticking up out of the ground, a little bit more 3D per se, that our 2.5D approach wasn't working. You can't just go into the top view of this data set and say, okay, follow this path because this is sticking straight up. So with this approach, what we're able to do is just come into any orientation, let's say here on this side view, and say, okay, this is my feature I want to extract or follow. So I'll make a fence around that. Select my my cell, in this case of the shape of the beam. Click Process Fence Data, and it's going to go through there. And give it a sec. And it's going to go through there and extract the lines for us, so you guys can see them there. Okay. And so then you come over here, do the next one. Now it's important that this is you do this on straight segments. You can't put a fence up around the big long thing that's bending all over the place and expect it to follow that. You're gonna have to do straight pieces at a time there. But yeah, the process
It does
is.
have some. It will change direction and orientation a bit, but
Yeah, I
not.
mean, if it's like sagging or not sagging, but bent a little bit, it'll accommodate all that.
Mm,
It'll also take any sort of rotation into account. You can have it, twist and things using this allow rotation option, which is not just specific to this by fence tool. You'll find the allow rotation option has been added to all the template extraction tools. That says, okay, allow plus or minus 5 degrees, and it we'll twist that template around to see where it fits the best and make sure that it creates the break lines
let's
with that twist.
Yeah, let's actually just elaborate on that. Just to give you a solid example, if you have like a barrier wall that actually changes orientation with the super elevation of the road, you can use this allow rotation, and it'll take 5 degree, it'll check between plus or minus 5 degrees, and it'll orient it tighter. And so, those are those are really things to do. Those are, and 2.5D, so to speak. Those are, for the 2.5D tools, this rotation works well. And again, of course, this is a 3D tool, and now you don't have to worry about, basically you just have to isolate or fence. You don't have to isolate the data. You just have to put a fence up. And does the fence give it the basic orientation and everything?
Yeah, so you
Yeah.
put the fence and it fits a line to that to get the orientation, and that gets it started.
That's right. So yeah, it goes and fits a line to the data. So okay,
And
that's
then
your.
it has to calculate the orientation.
Yeah, and then it has to go and calculate, how it's oriented. Yeah, it was a more difficult problem than we thought when we first started doing it, because you don't know how anything's oriented. You have that shape, but you don't know how to twist it. So this is very helpful, and we found our customers. And also, okay, so let's talk about making a solid model real quick. What can you do, Mounty?
Yep. So the other thing here that you can do too, just like a quick little tip, is if you need to make a solid model out of this, what's important when you're creating these templates is you create it in the order that you want the solid to connect. So when I created this one, I created this point first, followed by that one, this one, here, 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 and basically playing connect the dots so that when I go ahead and select all of these guys, I can say loft surface, make sure segmented loft is on, and then just click, and it's going to know how everything connects and just generate that 3D beam for me.
And what Mounty said, make your template. It's not your template. It's actually just those break lines, the red points, right?
Yeah.
That have to be in order.
Right.
So you can make the template any way you want. That's not a problem. And then when you apply the red points to break lines that you're extracting, make sure they go in an order that you'd want them to be attached to form for those break lines to form a plane, to form a surface. Does that make sense to everyone? I hope. Any questions out there? So you see what Mouty's doing there. So this will take some camber and some stuff into the equation. Some bend in it, some twisting, and we think it's very powerful. It works really well. Okay. So, and you'll notice also it actually goes right to the top. So it finds the last bit of data and says that's where it ends it. You might have to extend the bottom a little bit if you want to go to the ground, but that's easy. But it gets right to the top. And I think our customer there, I think it was Kiewit Construction, wanted to know where the tops of those were. So they were very happy with this tool. Okay, is it. Do we have anything else, Melly?
No, if you want to, did you want to talk about DPEGs?
Yeah, I think, while we're doing so, a couple of people haven't seen the DPEGs, we're always getting new people in, so let's do that. Just the DPEGs for so TopoDOT to Esri. So how do you get all this point cloud information? How do you share it with your in your GIS world? Now, again, TopoDOT for Esri does not have the tools that you see in TopoDOT for Bentley. TopoDOT for Esri is basically basic measurements, location, finding, just so you know. I mean, you could sit and click all the time and do a full extraction, but it wouldn't be very efficient. So the bottom line is, but when you want to share with, you extract this very quickly in TopoDOT for Bentley, in the CAD environment, and then you just basically you can pass that information on, so your GIS. Anyone using in the GIS world can actually look at that information, measure, identify, make changes, QA, QC what you've done, or they can add, subtract, whatever. So it's a great way to get that information in. So Maddie's going to show you real quick how that works. For those who hadn't seen it, basically every image, if you see the vectors down there, every image we have 4 vectors. We know where that image is pointing, right? So basically, what we do is, you have a point cloud. What we do automatically inside of TopoDOT for Bentley is we extract the data that is associated with those vectors, those camera vectors. So there you see your data, there you see your image, and so TopoDOT, all you have to do is basically go through, you hit a button and say, go do this. It's very completely automatic. And you convert to DPEG by camera, so you can click which camera you want. So you don't have to take all the cameras, that's important also. You can limit your, number of DPEGs to how much you want them. You can actually say what the radius, so we're gonna look 100 feet from the camera orientation, from the position. And then you can limit your megapixels. So, I mean, to be honest, you guys that are looking for road stuff, with like a lot of us are, 6 megapixels will do it. I mean, if they're trying to put 8 and 10 and 20 megapixel cameras, it just starts to be a lot of it, a lot of data. Limit it, and then you just basically converts there. You convert 2,300 images, so Mally won't run that, but it could take a couple minutes. And then what happens is, when you look back and Mally will load one of those DPEGs for you, the first one, you see what we've done, right? So that's pretty elegant. Everybody gets what we've done. And then, of course, we've done that in a few places. So if you load the next one, you kind of see how they even overlap a bit, but every image has, the next ones are just kind of one after the other. So every image, now, if you think about that, that's all it does, which isn't trivial, but, we do it, make it very automatic and very easy. And then the next step is these DPEGs are ready to first of all, anybody familiar with Topo Cloud? You can upload them to your own server. You can put them up in the Amazon cloud or anywhere else, and map drive, whatever you want to do. And then in ArcMap, for example, we kind of pick ArcMap because you're not supposed to get point clouds in there, but you can. And basically, so now you'll open that. You also have to install TopoDOT for ArcMap. TopoDOT is, and then you can give this to anybody. We'll let anybody have this, TopoDOT for ArcMap. And basically then it can locate it on the cloud, or in this case, it'll be in Mally's hard drive. He loads the project. The project tells basically where everything's pointed, where all the images are. And when he clicks, it'll go find the correct DPEG. It has channels. You see the channels information. You don't have to look at the other channels, but they're there. So if you click somewhere along there and you want to see something, say, pick something Mally, you can just click there and it's going to find the right image for you. There you are. There's a barrier. There's a, what do you call it? Guardrail. You want to put a line on that guardrail and give it an attribute. I'm making things up for Mally to do here. You're in Esri, just do it. Very simple. Again, if you have hundreds of miles of guardrail, do it in TopoDOT for Bentley. We do it automatically with templates, but you have to click and click here. But if somebody wanted to do something just to show you, it's not difficult. You see The circle tells you you're on the guardrail. It gets bigger and smaller depending on how far away the data is. So if you're up too high or something, you know, and you see those lines going down there. So there it is. And there's your guardrail. Okay. And you can see right away you got into the weeds a little bit. So where is that? No big deal. Anyway, so you guys get an idea. So right away, all these things you've extracted, now you can make all this data available to in the S3 environment, you know, which is really powerful. That's about it. Of course, you know, ArcGIS Pro it works on, and it works in Desktop Explorer. You want to measure? Thank you. Almost forgot. So you can measure the distance from that tree to that line, and it'll give you actually the two components. You can measure the distance from there to the line. There's your height, and then your XY is, you know, your delta XY is basically how far the projection and the horizontal projection is. You got your radius and you got your vertical projection. So you have your height and you have your distance. You're in S3, and you know you'll know anybody working in there will know what to do with that information. And obviously you can change attributes, things like that, put a location of something down on the road, all that stuff. So I think the real power is that we extract this for you automatically. We let you put it on the cloud, and then we have a very, very elegant way of you just bringing it into this environment. Okay. So anyway, anybody have any questions about that? I actually see Mr. Clayton Crawford is out there from S3. I was wondering what you thought of that. I'm going to unmute you. Clayton, are you there? Can I put you on the spot and ask you what you think? Oh, no, I guess not. Okay. All right. So anyway, let me. So that's about it. I think so. We've gone through all the new tools. Obviously, we're here for you if you have any questions. Let us know what your response, if you know what your experience is with the tools, if you need any subtle tweaks, or a lot of times it's just we can help you with the application of the tool a little better, or maybe a combination of tools. But keep in touch, and we're here for you. So that's it. That's it today. That's for release 10.6. Look forward to again seeing everybody, and keep in mind next May is TUC 18, where you'll meet hundreds of people that are using TopoDOT and in Orlando here, and you can actually get to another level with your compatriots who've been in a week of learning TopoDOT, and in addition to the technology, overall technology for point clouds and especially in transportation and corridors and the like, and infrastructure. So okay, all right, everybody. Thank you. I think we're going to sign off. Have a good day. And again, thanks for coming. Appreciate it very much. Bye.
Thank you. Bye-bye.